Welcome to our lectures on a flexible AC transmission system. Today is going to be our last lecture. We shall see some practical considerations and practical installations of the fax devices, and we shall conclude the course. So, nowadays there many fax devices are installed various part of the world. These are the 3-4 fax devices has been installed in USA around 40 years ago. Still it is working, thus it can talk about the reliability of the system. So, one is actually WPA advanced series capacitor, that is actually they used to say it is a advanced series capacitor, it is essentially a TCSC. Thereafter BPS Slater thyristor control series capacitor, and this is also TCSC. Thereafter you have a TVA, this is a state basically Solvian state condenser, that is essentially the STATCOM first put into the operation, and AEP first come out with the actually unified power flow conditioner. So, actually we shall take out the first case, that is advanced series capacitor as described. Essentially it was a TCSC, was name given by the manufacturer Siemens. There is a history behind it. Actually the writer of the famous book of fax devices, Yugi and the Hingorani, were both working in the Westinghouse. Then that part of the business was purchased by the Siemens, and thus they become the part of the Siemens business. To their Siemens, to their total series capacitor system, including a TCSC and a conventional series capacitor, that is mechanically driven. It was put into the operation in diplomatic term or bureaucratic term, we say that dedicated to the nation in 1992. This first of this kind of ASC was installed, and it was installed in 230 kV substations in western area of the northern Arizona in 1992 it was. So, thereafter around 35 years ago, the advanced condenser part of the WSC regional system is characterized by the long transmission line. So, you can see that there is a delta difference of it, and a large number of power plant, both hydro, thermal and many series compensator was placed in that line. So, for this reason that particular site was chosen for the shunt compensation, for series compensations, and fax devices was placed. And this ASC was needed to increase the reliable transmission capacity of 230 kV line between the Glen Clean and Seapork. This is the two places we require to send power in between, and thus we place it. And the Kenita substation was selected for the unique project because of its location of the middle of the line, middle of 190 or 400 kilometer line, 190 mile or 400 kilometer line. The surrounding system consisting of many 500 kV and 230 kV line connecting the substations, most of which locations of the large thermal power plant. And also there is a small local load about 50 megawatt supplied to the Kenita substations, and Glen Canyon Seapork 230 kV line was designed for an initial power transfer of 300 megawatt, but it has been found this line effectively carry a scheduled power was diminished in the 1960 due to the addition of parallel line of 345 kV and 500 kV path. So, actually its capability has been reduced because of the parallel path. In 1977, 230 kV phase shifting transformer was installed at the Glencairn substations and re-establishes the effectiveness of the 300 megawatt path line through this SHIPOC. With the power transfer on the interconnected network approaches the transmission line's ability to reliably serve the increasing load with the restrictions of the new building, with the restriction of the building new lines, because new lines will have a lot of constraint. For this we want that capability of the existing line required to be enhanced. That is the basic philosophy of the fax devices. The economic benefits adding a series compensation become a attractive alternative to improve the power line scheduling and transfer capability. In addition, 70%, that means actually 110 ohm and 330 megavar of the conventional series compensation was needed to increase the power scheduling capability by 100 megawatt. Thus, restoring is useful of its full thermal rating. So, we have to check the thermal rating. So, this ensure that it is within the limit of the thermal rating. However, this series compensation thyristors controlled provide additional benefit also. We know that damping can be provided and all those issues. This is actually the single line diagram of this ASC advanced series compensator or capacitor. So, this is basically the damping circuits, and this is the MOV, and this is basically your ASC, whose impedance can be changed to 50 to 60 ohm, and thereafter you have a conventional series capacitor which had been placed to the line, and you have a circuit breaker placed with an inductor, and you have also the circuit breaker placed with an inductor, and this is the damping network, and this is basically the single line diagram of this fax devices. The figure shows a simplified one line diagram of the series compensation in this Kenite substations. It consists of 255 ohm series capacitor bank, each rated for 165 MVAr of 1000 ampere. One bank operate in a conventional series compensation configurations, with second one bank subdivided to 40 ohm, 120 megavar conventional segment, and 15 to 45 ohm, it is changeable megavar with TCSC. Thus, for completely conventional operation, this series compensation can be set to various levels by the fixed capacitor. These levels are established by 55 ohm, 40 ohm and 15 ohm conventional series capacitor system. You can see this. This is 55 ohm, this is 40 ohm, and this is generally 15 ohm. By using the operations of the circuit breaker thyristor switches, a combination of 0 ohm, 44 ohm, 55 ohm, 110 ohm banks can be inserted into the transmission line based on the need of the operation. The use of 15 ohms segments as a TCSR provides the following advantage. What? Continuous control of the series capacitor compensations all the way up to 100%, and second the discrete step control of about 70%. Direct and dynamic flow of power, so that is also possible. Short circuit current reduction by rapidly changing the controlled capacity to the inductive impedance, so that can be done with the help of this segmentations. So, you trigger it, so ultimately current will flow through this inductor and it will bypass this capacitor. And SSSR means mitigation, that is synchronous resonance or subsynchronous oscillations. The ASC takes an inductive resistive impedance characteristics at SSR frequencies and thus actually detuning the damping of subsynchronous oscillation, that is basically a great cause of concern in any power system network. Thereafter, what else? Improvement protections and rapidly reinsertion of the series capacitor during the fault system. And so, thus what it will ensure that actually DC offset, because it will block DC, will not present, reduces the DC offset of the capacitor voltage within the few cycle. So, these are the few overall TCSC parameters. Nominal capacitive reactance, 9.5% series compensation with one module per phase, it gives you 15 ohm. Continuous effective capacitor reactance with nominal minimum thyristor control of 16.5 ohm. Inductive reactance will fully thyristor conducting, it is 3 ohm, and maximum dynamic range of capacitive reactance subject to 2 per unit of the capacitor voltage unit. So, this is something the insulation limit has been prescribed, and that can go to this capacitive reactance equal to 60 ohm. So, thus these are the ratings, and thus these are the advantages also. Nominal 3 phase MVR compensation, it is 45 MVR. Current rating per unit has been chosen for 1000 ampere base. Continuous overload will be around 10%, that is 1.1, it will be this value, and for 30-minute overload current we can go to the 33% more. So, current can be allowed to flow about 1330 ampere. 1 minute overload current, that should be actually this much of value, and it should be actually 16660 amperes, and operation with the ambient temperature range will be 40 to 45 ampere. So, the Kennedy thyristor valves are of modular construction and housed in an outdoor waterproof enclosure located one each phases of the series capacitor platform. Thyristor valve are cooled by mixture of deionized water and 50% glycol, which pumped through the fan cool, that means actually it is air cooled, force air cooled heat exchanger at ground level. The system also provides heating for the platform of the analog signal electronic processing equipments. So, it will also maintain the ambient temperature for those components. Each of the 3 thyristor valves has 11 bidirectional and parallelly connected thyristor pairs forming individual levels and having a current handling capability of 100 ampere each, that makes it basically the 1000 ampere. So, 11 series connected thyristor level. So, we have, this is actually put into operation in 92. So, actually this is one of the oldest fax devices. One level is redundant, allowing valve to provide normal service in the event of the failure of any one of the thyristor module. Thyristors are 100 mm cell diameter and rated for 3 K of 5.5 kV. The fault current at this site is only few thousands ampere, too low to be the factor in the thyristor rating. So, this is the one of the reason that fax devices can be placed and the cost of the fax devices does not increase. The thyristor arrays are linked to the advanced control system by fiber optic interference, that gives you the rated required isolation, and that helps you to operate from a distance also with SCADA or another interfacing requirement, which is used to send low energy firing signals and monitor status of the individual thyristors. The TCSC control and protection is digital microprocessor based. The open loop control carries output startup sequence to ensure safe insertion of the TCSC, monitoring of the basic system conditions including the line current, protection status, cooling system and thyristor valve status is also carried out by open loop control. The control module control mode requires constant impedance mode, constant current mode, thyristor switch reactance mode as the wait mode. So, it will change the status. In the constant impedance mode, each phase control is independently to balance the phase, but maximum TCSC impedance unbalance is automatically limited to 15%, that is equal to the 9 ohm. In case of the constant current mode, each phase has a closed loop current regulator which has the ability to maintain constant current in the line, but there might be an impedance mismatch and due to that load imbalance can be there. Thyristor switch reactor mode is the thyristor becomes fully conducting, so that it is bypassing. The switchover from 3 ohm inductive to control range to 15 to 30 ohm capacitive operation and vice versa can be used for power modulation, damping and oscillation. When it is required to be damping, then it will current will flow through L and R for reduce the SSR, that is subsynchronous resonance. While the study was carried out to simulate SSC stability and the transient program, the stability control was not deemed necessary for the installation and was not installed. The performance of Kineta AASC was evaluated with another one software called actually TNA simulator with the SSR insertion. So, we have done it and it has been found that the study and the on-site field measurement of the Kineta and the nearby 4 corner of the sense 1 generating session is confirmed that this TCSC appears inductive in the subsynchronous frequencies. So, it has a capability to damp out the subsynchronous oscillations. Since SSR is with 70% conventional capacitor is not a problem for this line, and because this TCSC appears inductive at the SSR frequencies, no special damping modulation features is incorporated. So, this is an inherent, that is there, it has got a SSR damping features. Please understand that any circuit, because capacity impedance generally it is basically XC equal to 1 by omega C and XL equal to actually omega L. So, what happen if frequency is reduced, this value basically is actually increased and this value is decreased. So, essentially at a lower frequency, what does it say, the 70%, so it will offer huge impedance, series capacitors, and it will not have a much problem in the line, right. The wait mode of the thyristors is between actually changing of the configuration. Once you try to change one configuration to the another configuration, it will take some time because there is a transient phenomena involved. We have seen that TCSC actually required to be switched on minimum transient requirement, and the capacitor operates at 15 ohm conventional capacitor mode, and that will ensure that transient free changeover. The thyristor switch reactor and the wait mode may be entered automatically from the constant current and constant impedance mode. If the system conditions are abnormal during fault or initial energization, then we can actually go for this changeover this mode. So, we know that basic type of the fax devices are shunt controller, series controller, power angle regulator, combined series and shunt controller, combined series and shunt controller. This is basically PAR and this is basically UPFC. Now we start discussing the overall fax devices and its philosophy. So what does this shunt controller do alone? It injects the current in quadrature with the line voltage. Since the current is not always quadrature, sometime it is also inject the real power to the line, mostly to meet the losses of the switches and the different part of the circuits, and it helps to regulate the line voltage and improves the voltage profile. And what it can do, it damps out the power oscillation. We have seen that actually while discussing the shunt, that from the equivalent area criteria. So it increases the stability as well as that it can damp out the oscillation. It improves the transient stability of the system. Main advantage of this shunt type fax devices is that it should have a less current rating. So only it sees the fraction of the current rating that required to be compensate the reactive power. So what happen, that is the biggest advantage of the shunt devices, that cost of the shunt devices will be less. It can gives you the good voltage profile, it can ensure the stability, it can actually suppress basically the problem of the transient. Full line current is not passed through the shunt type of fax devices. Then but what is the disadvantage of it, or what is the limitation of it? I should not call it disadvantage, it is the limitation that it cannot enhance the power handling capability of the line. So basic building block of SBC, that is the series VAR compensations, is basically the TCR, TCSC and TCR. TCR have it, we have seen just, TCR have the drawback that it will introduce a large amount of the harmonic into the system because of the switching, and it can be minimized by 1 by n segmentation of TCR by using different kind of transformer configuration like delta transformer with different pulse like 12 pulse and multiple of the 36 pulse. In that way we can reduce this actually harmonic content into the system. And another devices we can use, that is TCSC capacitor, and it should be switched in transient free mode. So therefore actually you have to wait for the time, either it is the supply voltage and the voltage across this TCSC voltage across this capacitor is same or it is at the minimum. TCSC never used alone, it is always with a combination of the TCR. So main fraction, let us see, you require 13.6 MVR to be compensated. You will have, let us say, multiple of 2. So 7 TCSC will be actually opened, that will give you the value of the 14 capacitive NVR, and thus you require to compensate minus 4 MVR, that definitely will come from actually TCR. So in that way it will operate. So we have seen that SBC can be classified as actually mechanically switched SBC, fixed SBC that we have seen right now, as well as TCSC SBC. Mechanically switched SBC are not very popular because of the slow response, trap energy, capacitor bank and very less switching life, but it can be economical and effective where actually number of switching is less. Same way we can have actually fixed switch as SBC, it is actually kept for the operation for the longer duration of time, and thus it will be keep on operating, and advantage is definitely what we have seen recently, that is actually TCR SBC. So that is has a huge advantage, and it is most popular fax devices in the rating of the TCR, and it is actually very low, and we have the splitting of this rating by 1 by n, where n will where actually we have a modulus switching. And about all this shunt compensation, this is basically a passive kind of devices. It is essentially inject a passive component capacitor, variable capacitor, but we can have a solution with the STATCOM where it generates this actually reactive power and the current by manipulating angle between the voltage and current, and this STATCOM is definitely, it is more preferred. So, there is a facts. First STATCOM was installed in Japan up to plus minus 80 megawatt within GTO in 1991, and these are the actually comparison with the SVC and the STATCOM. Injecting current is independent of the AC system voltage. We have already discussed all those issues, but we to recapitulate in conclusions. It can provide effective reactive power compensation at lower AC system voltage. It is same because voltage actually sag it is independent of the voltage sag as well. Capability of the exchange real power using suitable energy storage devices, and thus it can operate all the 4 quadrant. Transient stability is better than SBC because you have to wait for NTCSC for the transient free operation. Damp outletting power oscillation is very effective. Response time is very fast compared to this actually the passive element of SBC. Physical size is around 30% less than SBC, and cost and losses are little high considered to the SBC, but with the invent of the new technology and the new switches and its rating, ever increasing rating, we hope that this statement will change soon or already have changed. So, for high voltage applications can be implemented with the multiplex converter, it is to be used, but for the but it has a drawback, it requires a zigzag transformer, and a polygon transformer will increase the losses and the cost of the system. So, present trend is essentially to implement STATCOM with actually to shoot the requirement of the voltage level, we use actually multi-level inverter. Now, let us talk about the fax devices. It injects the voltage in quadrature with the line current. So, it is always not in quadrature, and same for the actually the shunt devices. Sometimes it also injects a real power with the line by using the energy storage device. It makes the system behave like a steep voltage source. So, what does the series fax device can do? It provides better voltage stability, transient stability margin. We all have discussed all those issues in the series compensation, power oscillation damping, but one of the basic disadvantages is that it has to provide the rating has to be rating in series. So, it sees the total voltage and the current rating. Device will be rated for the full load current. So, series devices can operate either voltage compensation mode or the impedance mode. These are actually GCSC are a impedance mode operation based on the transformer actually turn off delay of this actually GTO. It is analyzed by using the duality property of the TCR, and same like TCR to reduce the harmonic segment of segmented GCSC can be used. So, same way we have another fax devices in series compensation, that is TSSC, consists of the N fixed capacitor with bypass valve and steps like, and it will have a step like control. And TCSC, it is a capacitor bypassed by TCR. TCSC has 2 operating range around the internal circuit resonance in a capacitive mode as well as the inductive mode. Generally both are operate in simultaneously, but of course preferred series device is SSSC. It will inject the voltage, the power converter based series compensator, and is analogous to the synchronous generator. The main advantage of the SSC is that compared to these other fax devices, power flow is independent of the delta. So, it can in fax devices STATCOM was independent of the SAC, here actually it can independently control the flow of power, it is independent of the delta. SSC can inject positive as well as the negative voltage, SSC can reverse the power flow, though it is actually not required most of the cases. All other SSC, all other than SSC, all fax devices introduces actually subsynchronous resonance and problem of the subsynchronous oscillation, and this problem is not at all there, and thus no damping device separately required to be placed. And another is actually series parallel combination, that is essentially a voltage and phase angle regulator, what is we say it is PAR, and it is normally used for optimal loading of the transmission line in practical power system, cannot always be achieved by the prevailing transmission angle. So, it is prevailing in case of the short transmission line. It is in the addition of the phasor or the quadrature voltage of the existing voltage in order to change or increase the power flow of the line. PAR does not increase the transmittable power of the uncompensated line, it makes it keep the power maximum value constant, only it changes the actually the power flow in the wide range of varying delta. So, it can be classified as, that is, thyristor control power angle regulator and thyristor control phase angle regulator, switching converter based voltage and the phase angle regulator, and TCVAR and TCPAR. It can be continuous or the provide discrete level of control in steps. To achieve the reduced harmonic generation, thyristor step changer configuration must provide with the discrete level of control. Switching converter based voltage and the power angle regulator, it is same as SSC, it is same like TPSC, but injects the voltage not always quadrature with the line, and it is a combined series and shunt compensation, and from there we have actually the most modern compensation technique, that is UPFC. It is a interconnected fax devices of combination of STATCOM and SSC. So, it has all the 4 quartered operations and the power flow. It develops by using a back to back connections of the converter with the common DC link. STATCOM injects the reactive power and maintains the DC link voltage as desired by absorbing the real power. SSC injects the voltage with the desired magnitude and the phase angle, and multifunctional power flow control executed by simultaneous terminal voltage regulations, series capacitive line compensation and the phase shifting, all is possible, thus it is quite versatile device. No single conventional equipment has the similar multifunctional capability. So, thus UPFC is basically the solution, and thus thereafter you have an intermittent power line condition, it is essentially a series compensator. It is used for the compensating number of transmission lines in a given substations, we have discussed in previous class. The main function is to increase the transmittable real power over a given line and also balance the loading of a normally encountered multi-line system. So, fax devices in distribution systems are the follows. It is used for the mitigation of the multiple power quality problem. It is basically the D STATCOM. So, just rating will be less, and thus we can make it with the IGBT, and this is a very popular for the power electronics people, and they placed it in a wide range of applications. It is effective solution for the power quality problem generated by the current due to the load disturbance, such as current harmonic unbalanced and the reactive power injection. These are the problem of the power quality rather more than the power transmission. TVR, same way, we have a series active power filter. It is best solution for the voltage quality problem due to the source disturbance such as voltage sag, voltage swell, voltage harmonic, flickers, etc. And thereafter we will come to UPQC. UPQC is a hybrid connection of the shunt and series active power filter and designed for suppression of the multi power quality problem, as we have seen in UPFC. Thank you for your attentions. I am thankful to the team NPTEL for their valuable support, and I am thankful to my student Harish and Munir for actually make me ready for these presentations. Thank you all. We hope that these classes will be beneficial for all your future courses for industry, research as well as in academics. Thank you very much indeed.